In this topic, we are considering the energy, how in this form from one in any chemical reaction, how it's get converted into one to another form. Okay. Generally, we know on the basis of energy is following the conservation law of the energy. It means like energy is neither be created and nor be destroyed. Okay, it's always when it take a place in the chemical reaction, energy always be change their form. Okay, light light energy convert into heat energy, electric energy get convert into chemical energy, and chemical energy is allowed to convert into the electrical energy. Okay, so that's a form of the energy is allowed to get changed. Okay, so how this kind of the measurement, how we'll calculate the energy, how much amount of the energy is allowed to take a part in reaction. Okay, and on the basis of the how the resources is become efficient for us to ensure that much amount of energy is needed by the particular reaction. Okay, and how much amount of the energy is in the particular reaction is get changed their form, and from which form to which another form it's allowed to get convert. Okay, so like energy as we know, reactions are occur exothermic also, endothermic also. Exo means out, means in the particular chemical reaction the energy is giving out. Okay, and endothermic means where we are considered as the we are providing the energy for to run the particular chemical reaction. Okay, so how much energy is needed, how much energy is get obtained by the particular reaction, we are need to be measured how the energy get transferred from the surrounding to system or system to surrounding. Okay, so we consider as a energy in the form of like if it considers a heat. Okay, it can be given out means like in exothermic reaction or can be taken in for like consider as an endothermic reaction. Okay, from the surrounding, any kind of the reaction when it occurs that will consider as a in one system form, and the outermost space of the system is considered as a their surrounding. Okay, so there's always be the exchange of energies occur in the system and surrounding. If system gives the energy to the surrounding, so means this type of reaction is considered as a exothermic, and the system needs the energy from the surrounding, that will consider as means the reaction is like endothermic. Okay, so now this kind of the if the changes occur, how much energy is get transferred from one to another form, there need to be some kind of equipment, like for example we are using the calorimetry. Okay, which is discussed about the how much energy is get consumed or get given out to the surrounding by the particular reaction. Okay, for example, if we are discussing about the energy changes from the combustion reaction, means combustion reaction as we know will consider as a you are burning the fuel in the presence of oxygen. Okay, so in this case if you are allowed to get measure the how much amount of the heat energies get transferred, so simply you can measure by you are taking one fuel. Okay, like here we are having one fat burner. Okay, and here in beaker you are adding some water. Okay, so usually in that case we are adding one thermometer in that. So here that fuel we are using. Okay, the glass container, first we are measuring the cold water in the calorimeter, then after you are recording the starting reading, what is the temperature reading is mentioned here, comes here before we are providing heating. Then after heat the water, we're using the burning of fuel. We're using the spirit here. Okay, and then afterwards, the final, how much spirit you are taking. Approx you are taking like 50 ml of spirit here. Okay, till this frame you are providing, and after the reaction get completed, you're measuring the reading, how much temperature is get increased after completely the burning of complete fuel. Okay, then you are having three readings here. First, in the spirit burner, how much amount of the spirit you are filling before the experiment and the after the experiment. Okay, that is considered as a mass of the fuel to be burned can be found. Okay, suppose approximate you having 100 ml there. Okay, and when the reaction finished, your value comes left is having 50 ml. So means 50 ml you are consumed. Okay, so that is considered the mass of the fuel now be burned can be found. Then afterwards you are having the reading of temperature range, means before the reaction start and after the reactions. Okay, so after this kind of the temperature change is provided, with this help of these readings we are considered as a, we can easily calculate the energy, how much energy is released by the fuel after burning. Okay, so this method is also get information of the how much energy is released by the fuels when you're providing the heat. Okay, so in that case we are considered as a, but in that case the error which can be arise because this is like a open container. Okay, because if you are consider this one is system, so that is completely open with their surrounding. Though some amount of heat is allowed to loss from system to surrounding. Okay, that measuring is like a typical for this kind of experiment. Okay, we're getting the little bit average value, but in that case we are not getting the completely accurate result because there is an error of heat loss to the surrounding. Okay, so in that case, to remove this error, we can using the insulating sides. Means you are adding the one lead container like this. Okay, means you are making a one closed system. Okay, in closed system, from system to surrounding, the heat is not allowed to get pass. Okay, so due to that, the loss of heat is not get visible in that experiment. Okay, so in that case again you are doing the same things. First you need to the known volume of the reactant part, then taking the reading of starting temperature, then add the second reactant in that case, then again you are considering if there is a lead in the reaction mixture, then what kind of the temperature ranges occur. So this is helps us to find out the calculate the energy change occur for the particular reaction. Okay. Yeah. So in that case we are using this particular formula. This one is Q is represented the how much heat energy is get transferred. Okay, means amount of energy. Then M is shows the mass of the fuel. Okay, like you having the spirit. Okay, so how much gram is 50 mg or 100 gram you have something. Okay, so how much mass of the fuel you are using to be heated. Okay, then the C we are considered as a specific heat capacity. Heat capacity means we are considered as the how much amount of heat is needed to increase 1 degree Celsius temperature of any substance. Okay, that is considered as a heat capacity of that. And specific means it is like under specific condition. Okay, where we are measuring animals like for their molar concentration, like you can say for the 1 degree Celsius temperature of 1 mole of any substance. Okay, the concentration and the condition you are specified, so that's why they are considered as a specific heat capacity of liquid. That value will vary for each and every substance. Means water having different heat capacity, another one substance having the different heat capacity. So we need to measure all these three things. Okay, and this del T is represented the temperature change before the reaction and after the reaction. Okay, means before the reaction if I measure temperature mentioned at T1 and after the reaction temperature mentioned as T2, so del T is equal to T2 minus T1. Okay, so this formula we are using to measure the complete how much amount of the energy is get consumed for the particular reaction. For example, specific heat capacity is a constant value for water is 4.2 joule per gram per Celsius. Okay, and for this consider as a value is also sometimes is used for the liquid if it is not water. For general liquid term we are using this kind of heat capacity. Okay, for example if you are having acid, alkali and the other solution also. Second one we are considered as a energy is measured for the per joule. So 1 kilojoule value is equal to thousands of joule. So the unit will come kg per mole. Okay. Now the energy of the food as we know is measured by the calories one. So the unit for the food system not any kind of the other unit. So there we are unit we are considered calories per gram. Okay, not kilojoule per gram. Okay. Now, like for example, one reaction will occur. You having 50 centimeter cube volume of acid. You are adding with same amount of alkaline solution. Okay, means the total volume you having 50 acid and the 50 alkaline. Okay, now you are doing this reaction acid and the alkali. This is like reactant 1 and this one is reactant 2. Okay. Yep. So both you are allowed to, before you are mixing together, you are measuring the temperature. Okay. Then once they are allowed to get react to each other and you stir this mixture, you see your temperature from 18 to rise up 18 to 20 degrees. Okay. Now you need to calculate the amount of energy. Primarily you will getting this if you need this formula, so you need to get these three values. Okay, temperature change 18 to 28 means 10 degrees Celsius difference. Okay, then C specific heat capacity because it's liquid we measuring 4.2 as a constant. Okay, then Q value it shows the how much amount of the reactant, that is 50 centimeter cube acid and 50 centimeter cube alkaline, means total amount is 100. So the mass value is 100. So for this equation we can put Q 50 plus 50 100, C value is 4.2, and the temperature value is change is 10. So if we are multiply all this value, you will getting 4200 joule. Okay, means for 100 gram of that mixture to rise up 10 degrees Celsius of temperature, we need around 4200 joule energy. Okay.
Yeah.
Till now, any confusion with that?
No, I have no confusion.
Like for example, in more simple consideration, if energy from any kind of the fuel, if you are considering, okay. For example, you are burning the ethanol, the combustion reaction you run. Energy spent when you are using the ethanol, and how much energy is released to heat up the 50 gram of water. Same thing you'll do. Primarily, what's the starting temperature? Then afterwards, after the reaction, how much the increment is occurring in the temperature. Then mass of the fuel is spread. What is the mass at the start the reaction, and what the mass after end of the reaction. Okay. First temperature change 41 minus 19, its value this one. C value is constant because its water is liquid, that is constant value, and mass value we are measuring here. We have the overall value we are taking around 50 gram of water. Okay.
Yes,
so primarily you are getting this value. Okay. But this value shows for the complete fuel what you are taking. Okay. Because here you see there is completely fuel is not get consumed. Initially you have 40 gram, but after the reaction it's converted into 38.5, means only 1.5 gram is reduced. Okay. So this is the value you will get in the complete 40 gram. Okay. So you need to get the value only for 1.5 gram. Okay. So due to that, what we are doing, we are divided this 4.62 by 1.5. Okay. Then
yes,
afterwards you will getting the energy for per gram of mass of any kind of substance, how much amount of energy you will need it. Okay.
Yeah. Okay.
That's the for both of experiments you can consider it. But this experiment I have only one problem, as I told you, that is having a problem of the, because this burning combustion reaction is occurring in the open space because it needs the oxygen. Okay. So due to that, some amount of energy is released in the surrounding also. So in that how much amount of the energy is released in the surrounding, that amount of energy we can't be calculated. Okay. So that kind of the problem is arise in that kind of the process. If you having the journal reaction like the neutralization reaction, so in that case by the help of this same formula you can easily calculate the energy value. Okay, and the same condition. Okay. So in that case, as we are consider as a for exothermic and endothermic, as we consider as exothermic means you are giving out the energy, means that value will consider as a negative one because reactant have more energy, and when the product convert from the reactant, it an amount of energy is released. So the energy term is shown in the negative side. Okay.
Yeah. Okay.
because it's exothermic means it's have more and it's have less. Okay, and energy always be difference of energy is calculated by product minus reactant. Product have less and reactant have more, so value come in negative. Okay, and the same thing if you are consider as a for the endothermic, reactant have less, reactant need to absorb energy then convert into product. Okay, always energy calculated product minus reactant. Okay, so here product value is more and the reactant value is less. So this value is always comes in positive.
Positive, okay.
Okay, so means endothermic reaction value, the energy change always give the positive term. Okay, because here the energy is consumed, energy is added, so total amount of energy change value come in positive sign. Any energy change is shown by the particular reaction by the positive sign like 1.34 kilojoule per mole. So means by this positive sign you can easily find out this reaction is endothermic. If I mention minus 33.8 kilojoule per mole, so means this sign is shows this reaction is should be exothermic. Okay, so this kind of the difference we can measure by the positive and negative ion surrounding the any kind of the conditions. Okay, for example, we are considered as a like electrolysis process and other kind of reaction. They are most commonly processes of considered as a endothermic. Thermal decomposition is also most common example because thermal decomposition means by giving the temperature you are breaking something. Okay, so this type of reaction are considered as a endothermic reaction. Okay, till now do you have any doubt and any confusion with this part?
No, I don't have any confusions.